So we're going to go over 10.5 inverse matrices and systems of equations. So our objectives are going to be able to represent a system of equations using 2 or 3 variables in a single matrix. So we can actually represent a system as a matrix. And we're going to be able to find the inverse of a matrix and solve the system linear of equations by using the matrix. Now, most of this, we're going to be using the calculator to figure out, but it's really, really, really important that you know how to do this by hand, or at least that you understand how to do it by hand. Now, here's our first essential question. How do you solve a matrix equation? So when it comes to solving a matrix equation, we're going to sort of link it to the way we solve a regular linear algebraic equation. So I know I kind of gave you that example, but I'm going to do it right next to the example that we're going to be doing, just so you can kind of see the difference or the concept wise. So let's just say that you have a matrix A, and that is being multiplied by matrix X, which represents the variable matrix, and is equal to another matrix. Okay, and remember, this represents your variable matrix. So if we compare it to the matrix right to the side of that problem, we can see that this represents A, this represents X, and this represents B. So how would we solve this problem algebraically? Let's look at the right side first. So if I'm solving this problem algebraically, the first thing that I'm going to try to do if I'm solving for X is to get rid of A. Now, normally, don't write this down yet. Normally, I would say go ahead and divide by A. That turns into a 1, and then, you can kind of keep going. However, this process does not work for matrices. So I can't just divide a matrix by another matrix and it will somehow equal 1. So how can we make a matrix equal into a 1? Well, if you remember earlier in the notes, we can actually create an identity matrix by multiplying a matrix times its inverse. So what we're going to do is we're going to multiply matrix A times its inverse. Now, based on the rules of math, whatever I do to one side, I got to do to the other. And then now this becomes a 1, and I'm left with the identity matrix times X is equal to the inverse of A. I'm going to do that in a different color. So the inverse of A times B, but remember, the identity matrix acts as a 1, right? It's just a 1. So what happens when you multiply something by 1? Well, it just becomes itself. So technically, identity times X is just equal to X. And now all you got to do is figure out what the inverse matrix of A times B is equal to. And that will give you the answer. So in essence, that's what we're going to be doing to solve this variable matrix. And this is the process that I want you to be able to understand algebraically. All right, so let's go ahead and do that. So the first thing we're going to go ahead and do is we need to get that variable matrix completely by itself. So we need to get this completely by itself. So the first thing that I'm going to do is I am going to multiply this by its inverse. Now, I literally just used my calculator, so I know that the inverse matrix is going to be 1/2, 1/4, 0, and 1/2. And remember, whatever I do to one side, I'm going to go ahead and do it to the other. So I'm going to rewrite this because the order matters. So that inverse matrix is going to be there. So that means I'm going to have, what's going to happen to those matrices? They're going to become a 1 or the identity matrix. And now I'm going to be left with the variable matrix. is equal to the inverse matrix of the original one, which was 1/2, 1/4, 0, and 1/2, times the matrix that was on the other side. And now, if you compare it to our earlier example, this represents the X, this represents the inverse matrix A, and this represents the B. So if I want to solve the equation, all I got to do is multiply those two matrices right there, which I'm going to go ahead and do that with the calculator. Now that I did that with the calculator, it seems like the result, oops, sorry, hit the wrong button. It seems like the result will be our variable matrix is equal to 3 and 4. And if you match the letter, that represents your X and that represents your Y, which means X is equal to 3 and Y is equal to 4. And that is our answer if we are trying to solve the equation by using matrices. Now I'm going to quickly switch into the other screen. I want to show you guys how to do it using the calculator. So whenever you have a minute, or if you need to pause it, go ahead and pause it. And then just go ahead and turn the page over. So now what we're going to do is we're going to go ahead and solve this system of equations, which you should notice that there's an X, there's a Y, and there's a Z variable. So the first thing that I'm going to do is I'm going to rewrite the system using a matrix. And I'm going to separate this in 3 different sections. Well, actually, I'm actually just going to rewrite this as a single matrix. All right, so here's what I'm going to do. I'm going to rewrite this, the whole system, as a matrix. And notice that we have 1, 2, and 3 rows. And we have 1, 2, 3, 4 columns. So I'm going to make a 3 by 4. And I'm just going to draw a line there that simplifies or that represents our equal sign. All right. And all I'm going to do is I'm going to write the coefficients. All right. So that's going to be 1 for X, -2 for Y, 4 for Z, and then 9 as the constant. Now on the second row, we got 2 for X, -8. Ooh, actually that's a Z. So we're actually going to skip that because it doesn't seem like we have a Y value, which means it's going to be 0. And then now -A represents our Z. Okay, it's very important that you don't mess up the order. It's X, Y, and then Z. And on the last row is going to be 3 for X, 1 for Y, -2 for Z, -1 as the constant, and I forgot -24 as the middle constant. So that represents our matrix. What I want you to do right now is I want you to go ahead and take a few seconds and input that into your calculator. All right, so notice that I'm on my matrix and I created a 3 by 4 matrix, and you can see that the coefficients match: 1, -2, 4, 2, 0, -8, 3, 1, -2, and then the constants match. So once you create your matrix, which in my case is matrix A, I'm going to go ahead and click second, quit, and I'm going to go back to second matrix. You're going to scroll over to where it says math. And you're gonna scroll all the way down until you find RREF, which is letter B. Go ahead and click that. And then you're gonna go back to second matrix. And you're gonna use the matrix that you use. In my case, it was matrix A. You're gonna click enter. You're gonna click enter again. And this is what we got. I'm going to tell you what that means in just a minute. All right, so this is what you should have gotten on the calculator. We're gonna try to figure out what it means. So this is basically what it means. That first row, notice that only the first element is 1 and everything else is 0. This represents your X value. On the second row, everything is a 0 except the middle term, which represents your Y value. And finally, the last row, everything is 0 except that last value right there, which represents your Z. So remember, this line represents the equal sign, so you can guess that X is equal to 1, Y is equal to 2.5, and Z is equal to 3.5. And that is how you're going to be solving a system of equations using matrices. Now, remember the first example that we went over, that is just so you understand how to do it by hand. But from now on, I don't want you to be solving by hand. I want you to be using the calculator to solve the matrix.